So good morning, everyone. Hi, my name's Robert. I'm a product manager at Databricks.
Hi, my name is Jan. I'm also a product manager at Databricks.
We're both working on the workflows. Good to see you here, nice and early. Was it tough after last night getting up? So I don't know, a quick raise of hands if you attended the session yesterday on workflows, just to get a feeling. Okay. So in the first couple of minutes, we're going to go over a few of the value propositions again, just for the folks that weren't at the session yesterday. And then for the most part of the session, we'll be going through 3 demos to show you how to bring those workflows across to Databricks. So let me get started. Okay. So first of all, let's consider why we should migrate our workflows to Databricks. So there are a couple of reasons, but I want to start with one of the big ones, and that's really about improving productivity. So if you're a data engineer or an analyst or a data scientist, and you're working, on some code or on a query or building a model, and you want to and you want to kind of run that thing and connect it to other things, and let's say something goes wrong, and you want to go back, edit the code, and now you want to go back and run it again, and this time you want to see the results, and maybe you go and see the results. So some of these workflows that you're running, if they're running in production on time, you could maybe the only reason to go back and look is like when you have a failure. But in the initial phase of running workflows, from experience, I can say there's a lot of going back and forward in those three separate parts. So, running the workflow, looking at the results, seeing if it meets expectations, and then also editing code, queries, making updates, and going through that cycle a number of times. And in the lakehouse, we make that really simple. So it's one environment. And you'll see in the demos later as well that moving between those different responsibilities is very easy. And we believe that this helps really improve productivity for your users. And again, workflows is about being able to run anything. So for the most part, we're going to see folks running notebooks with Python or Scala. We're going to see folks running SQL queries against our data warehouse endpoints. We're going to see folks running things like dbt, and we'll look at that one specifically today. But it could be arbitrary Python. And yesterday I mentioned as well, notebooks are a very convenient way for packaging that up, including the dependencies, and the dependencies are then isolated to that notebook. But we also support wheels and Python scripts and Java. So there's quite a breadth of things that you can actually run. And you can call out to any external systems as well. So the proof is in the pudding. And at least 30% of our workloads are non-Spark, and 10% are single node clusters. And you can choose very small instances. So if you're just running let's say some small Python jobs, and you don't need a lot of compute power, that's quite easy to do as well. And with the possibility to share the cluster over your tasks, so cluster reuse, that means you're not wasting time spinning up additional resources or reinstalling libraries as well. So Databricks is fully managed. We'll see those numbers again in a moment that, for the folks who were here yesterday, in the other room yesterday, saw them, and at the keynote. But yeah, just really want to hammer home this point that Databricks is a fully managed service, and Workflows is a fully managed service. So you really don't have to think about the operational side. And I think there's lots of ways that we can kind of show you this, and if you're using the product, you'll experience it yourself. But I think the numbers kind of speak for themselves. 10 million VMs a day, and our availability is 3.5 nines. And again, you have to zoom in to really see that we go down to 3.5 nines. So half our engineering team in Amsterdam, which I guess tallies about 100 at the moment. Yeah, so half that team is there to really make sure that Workflows is a product that's always available, up and running, dealing with any cloud issues. So, of course, these things aren't free. There's lots of there are lots of things under the hood that are going on. And that's why we have a team constantly improving that service so we can guarantee this uptime. And that's why we can run 10 million VMs a day for our customers. So the reason we see, and when we speak to customers, obviously we're doing a lot of that to kind of improve the product. And feel free to reach out to either Jan or me. You can just our first name and last name with a dot in between at Databricks. If you want to schedule any time to talk about like features you would like to see in workflows as well. But when we go through adding features with our customers who are like prioritizing them, these are the three most important things to them. Like this are the three categories that we see those features coming up time and time again. So it's about reducing the operational overhead. So we see examples of that today. We see like Git integration, for example. So if I'm going to have my code already in Git, I don't want to have to copy this over to a workspace or whatever. I want to be able to use Git directly. Improve production reliability. So this is again, this is more on our side, but yeah, if we have customers that have issues, then we're looking at those, doing root cause analysis and making sure that we keep that level, that high bar of 3.5 nines. And I think the last one is where we get the most input from customers, and where we're hopefully hear from yourselves if you reach out for features that actually make it easier and makes it more productive for you to work with workflows. Examples of this that we've seen recently is when we look at the DBT task, you'll see that there's a possibility to specify all your packages for that specific task. And if you have another DBT task that's running some other models or different versions, then you can specify other packages if it's required as well. So that's kind of we're really looking to make sure that those common use cases our customers are using are really built well into the system. So without further ado, let's get on to some demos. Jan.
Thank you, Robert. Yeah, so I'll be walking you through 3 different scenarios, a very simple one, a slightly more complicated one, and then a quite different one. And the goal here is really to show you how easy it is to both have these kind of workflows within Databricks without having to rely on an external orchestration tool. And yeah, show you the value that Robert was just talking about, especially the fact that having everything in one place where your codes, artifacts, so your notebooks or your Python scripts or your jars, your data itself, which is stored in the Unity catalog or in your Hive metastore, as well as your orchestration, having everything in one place with the same users, the same permission models is super valuable. So what I'll do is for each of these scenarios, I'll show you kind of the scenario itself. We'll go through kind of the use case. I'll show you how this is done nowadays frequently with other external orchestrators, and then I'll show you basically how to recreate the same functionality within Databricks while gaining those benefits that we just talked about. So this is a very simple scenario where someone wants to orchestrate a few things in the lakehouse. There's 2 notebooks that either are SQL notebooks, Python, Scala, doesn't really matter. These can be created by data scientists, data engineers, SQL analysts, and after both of these have been executed, maybe they run on a nightly basis or whenever new data comes in with our new file arrival triggers, then we want to run a SQL query, so that's not a notebook, a SQL query that joins this data into a new table. And that way we make sure that every night or whenever new data comes in, this new data is available. So let's take a look. And in this scenario, we have an Airflow example. So somebody who is quite code savvy has set this up. This can be hosted somewhere, either on your own cloud environment or on a managed service. And this is exactly what it's doing. So Databricks contributes to an Airflow provider to make it easy to orchestrate all kinds of things in the lakehouse. Let's take a look at what that code looks like. So here you can see here's the Databricks Airflow provider. We define a cluster with the different settings that's available there as a dictionary in Python. We define our SQL query, which is the last task in our DAG. And then this is where we define our DAG. So how frequently should this be running? Which tasks are there? So here you see those 3 tasks that were visible in the DAG. And here we define our dependencies between between these tasks. So here it says that after sales data is done, join data should be done, should be executed, and the same for clicks. And as you can see here, we define our SQL here. We have our operators with the references to the notebooks. So now we've decided that we want to make sure that orchestration happens in the same place. Maybe we want the SQL analyst that wrote these tasks to be able to own the creation and management of these workflows themselves. And being able to do that in workflows without having to reside to Python code might be beneficial. So let's take a look here. This is our a Databricks environment. I've already set up a job with a single task here, which is this clicks task. And let's go over what's happening here. So we can choose what type of task I want to run. So in this case, we have these two notebooks, but there's all these other different tasks that we can run, including code artifacts, DLT pipelines, DBT and SQL, some of which we'll go into in a bit. I can choose my notebook, and here I can choose what cluster to use. So as you saw in Airflow, you can define all these different settings, but you need to know these in advance. And here I can actually choose in the UI what kind of cluster I want to use. And we have different options here. We can use a job cluster, which has some specifications about the cluster that we want to start as soon as the job starts. And the lifecycle of this cluster is really tied to the job. So the second that the job starts, we'll spin up the cluster. It will do what is necessary, and the second it's done, it's shut down. And this is for job compute prices. So these are the lower DBUs, which makes it cheap to use. And then together within workflows, what is different from other orchestrators is you can have multiple tasks within a job that reuse the same job cluster. So that means that the first time a task needs it, we start it for you, and it's still available until the last task is finished. But you can also use interactive clusters, so there's instant startup time. You can parallelize tasks over a lot of things. And just to show you here, I can make a change to this cluster, and this is a full UI for making all my changes. All right, so let's take a look. So we have this clicks task already. I want to add a task for the sales data. So here I go to it's in my user folder. I go here. In this case, I don't want it to depend on anything. I want it to run in parallel, but here you can see I can choose the same job cluster. So now both of these tasks will be using the same job cluster. And now we want this SQL query. So let's take a look. Let's go back to our code. So here we have the query itself. And what I will do is we'll go to our DB-SQL environment, which allows us to query directly on our warehouses. So what I can do is here I'll paste in this query, and I can immediately just run this and try it out. So let's this will actually update it. So let's do we have a nice code completion, and now I just run this, just so we can get a sense for the result. And here you can see the result of these two tables that were combined. And let's remove this. I can save this. I can give this a name. So the join query. And now if I go here, I can now choose to choose the SQL task. So this is our join query. And the SQL task type allows you to do multiple things, orchestrate multiple things in DB-SQL. So that allows us to execute queries, just like the one we defined. We can refresh our dashboard so that we can say, now this new data has come in. We've processed our silver and gold tables, and now we want to refresh the dashboard so that when my CEO opens up his laptop during his first coffee, he gets the freshest data available. And we can set up refresh our alerts. So let's take a look. We can now select our query that we just defined, and it shows the most recent one. So I can just pick this one. And I do want to set my dependencies because I want to only run this after my other two tasks have finished. So I'll select both of these. And you can see here now that things are defined with the right dependencies. What I will actually do is, because we can use an existing cluster that's already there, which reduces the kind of startup time. I'll change that quickly here, and I'll just run this now. So you can see here a run is starting, and we can see that both of these tasks are starting, and when both of them are finished, the join query will run. Right, that might take half a minute, so given the time, let's go to the next case. So the next case is going to be very similar. It's basically an extension of the case that we just saw. But in this case, we're, instead of just doing notebooks and SQL queries directly, we want to maybe interact with external services. So maybe you have an API from your vendor that you're working with that you need to pull data into your lakehouse, or you want to notify some external system that things are ready. And in Airflow, you can use things like the Python operator to execute some Python queries. But the nice thing about Databricks is that, as Robert was mentioning already, because you can have your dependencies tied to your notebook with your notebook libraries, you can actually have all these different tasks be completely isolated from each other with regards to dependencies. So you can have different library requirements that are maybe even conflicting with each other for your different tasks. And yeah, you can use your notebook or your Python wheels for maybe that are published through your CI/CD pipelines to make sure that the right things are happening at the right time.
Yeah, just a quick best practice tip there. If you're looking to isolate, use that notebook and use the notebook scope library. So it's just pip install in the notebook itself. And if you're looking to have that library on the shared cluster, so that you can use it across different jobs and you don't need to reinstall, then install it as a cluster library.
Yeah. So let's take a look at what this looks like in Airflow. So we can find my cursor. Yeah. So here, this is similar as we saw before. In this case, we added a second query that wants to join this data from this external source, which we feed into Delta. And then we have this notify task. So here I import these functions that are executed by our Python operators, and we define our dependencies here. So that looks like this in Airflow. We can see the three different dependencies here. We have our SQL operator that allows us to execute SQL against our warehouse. We have our submit run operator, which executes notebooks. And we have our Python operator that executes Python on the local Airflow executor. And in this case, in the workflows, we will be using the notebooks as a replacement for the Python operator because of the dependency management, and it's easy to author within the UI. So I've already prepared this one here, but I want to emphasize again that in this scenario, and what we see with our customers is some customers will have jobs that have like 50, 60, 70 tasks. With these external orchestrators, you're not able to use cluster reuse. So, and that really saves a lot of time with startup overhead, and it saves a lot of costs because you can get more parallelization and lower startup times where you're not paying DBUs, but you're still paying your infrastructure to your cloud provider. And I want to highlight something that we added a while back. So let's go into this DAG. And this is one of the things I want to show where it's easy to navigate between the different layers. So here we have our job definition. I can go here and I can take a look at my notebook. So this is faking some API calls. And let's say I just made a typo. Maybe something went wrong when I was making a change. And now if I run this, this task will fail because there's a syntax error in there. While we're waiting for this to start, let's take a look here. I want to highlight some other things. So here we have the same join data task that we had in the previous example. And because Databricks understands quite a bit about the different workloads we're orchestrating, we can do a lot of nice things, like in this case, highlight the SQL query itself. You can link immediately there, so if there's something wrong, you can live change it or edit it to within that context, so that basically the time between noticing an error and making the change to make sure that your output is correct and that you can just focus on working on new things again is minimized. All right, let's take a look at our run. All right, so we can see here there's been a failure. So of course, maybe this is a demo example, but in some cases, especially when you're dealing with like machine learning models, inference pipelines, these jobs can take up to hours, right? So in this case, maybe our sales and clicks tasks were very expensive and very heavy, but they were successful. The problem was that our download data that I made a mistake in excuse me, that I made a mistake in the code base. And you can see here that there's an error. So let's go and try and fix it. So I can immediately go to my notebook and I see the syntax error. I think to myself, what did I do? And now, after making that change, I can actually go back to the run. And here you can see that now we can try and fix this in place. So we can repair the run without having to run the different steps that were successful in the past. So I click here, I see which tasks will be executed again. Those were all the ones that were not successful. And I can even override certain parameters to maybe fix something or make sure that I have the flexibility needed to make sure that the output is correct. So I'll click on the repair. You can see now that these are basically back to pending. They're going to run again. And hopefully this time successful after I've fixed the mistake that I did.
So just while Jan moves on, just to call out that, I mean, you see how quickly Jan is moving through creating the DAG, going to the code, fixing it, looking at the run, repairing it. That's the experience that we want to kind of continue to extend and amplify on Databricks Workflows. So it's really quick for your users to move across those different jobs to be done.
Yeah, all right. So now we can see that download data is successful. Now join all data that's dependent on the previous two tasks can continue because the dependencies are met, and now we can notify the system. So then I want to go to the last example, which is slightly different than the previous two that we saw. So who here is familiar with dbt? Who is using dbt on a daily basis? All right, so dbt is a great tool for allowing you to define your models in a very SQL-centric way, define the dependencies very explicitly, and store that in Git and use that basically as your single source of truth. You can have your code reviews over that. But these models, they have to run somewhere, right? So that's in a sense, that's part of your orchestration, is running these models. But it's very SQL-centric, and in a lot of cases, you can basically propagate your models to silver or gold, but you might want to do things afterwards, like whether it's updating your dashboards or maybe training a machine learning model on top of the data there. So in this example, you can see we have the dbt component where your models are updated, and then we want to do some very model-specific feature generation to prepare our data for our machine learning model, and then run batch inference on that model on those generated features. And in this case, we use ADF to do these last two steps, and we have maybe like a cron job somewhere to run our dbt models. But the dependencies between these are very clear, right? Like we first want to update our models, and then we want to run our feature generation specifically on these on this new data. But it's very difficult to make that explicit. So we recently added in preview DBT support, where a new task type that we have allows you to connect your job to a Git repository that contains all your DBT models, and then you allow you to run them, and then have other tasks that are dependent on that. So this allows you to basically make this dependency very explicit, make sure that your models are updated on time, and then have downstream dependencies based on that. So let's take a very quick look. We're good on time. So here I have a Git repository with the Java shop example, which you're probably all familiar with. And I can even add things here like my notebooks, right? So with Databricks Workflows, we allow you to connect to a Git repository and use code artifacts in there for your tasks, so that you can make updates to your notebooks or your DBT models or whatever, and your job will just pick up a specific version there, whether it's a branch or a specific tag. And then here I have an example ADF pipeline that does the feature generation and the model inference. But in this case, as I mentioned, these dependencies are quite implicit. So we're using a very frequent way of doing that is using time, where you say, okay, at 8 in the morning, I'll run my DBT models. That should take about half an hour to propagate fully. So just to be sure, I'll run this other thing that's dependent on it at 9 in the morning. And that costs time, and sometimes maybe there's something goes wrong and you run this downstream pipeline and the data wasn't ready yet, you're spending more time on it. So we wanna make that more explicit. So here I want to create a new job. I can, as you can see here, I can choose the type. I'll choose DBT, and here I can choose a Git provider. So here I can pick a repository. So let's go take this one. That's not the right one. I can choose, as I mentioned, I can choose what I want to tie this to. In this case, I'll just take to the main branch. So anytime code is pushed into main, then this will be picked up by this job. And here I can choose whether if it's a subdirectory, and the schema is basically the schema that these models are going to be pushed to. So in this case, I set up a schema called dice demo, and that's where our changes will be pushed to. So, and here, what we're actually doing is we allow you to run multiple DBT commands. So you can have like a test command, you can update your dependencies, or with the DBT run, which is kind of the main goal. You can also filter on specific tags, so you can only run a subset of your models, maybe run a subset of your models 6 out of 7 days in a week, and 1 day a week you run the full one. That really depends on your use case. And again, you can choose your cluster here. So after I create this, I can now add tasks that are dependent on this. So after we've successfully run our DBT models, now we can do the feature generation and the schema inference. So that way, we know for sure that the data is ready, and we're not waiting unnecessarily for doing the things that we actively want to do. Because transforming your data is always a step into your final destination, but it's a really important one. So this way we can model that more directly. So let's do it. So I can choose the notebook from my Git repository. So that way I can make my changes through standard code review cycles and standard GitOps without making sure that these things are aligned. And I can make it dependent on this. Given the time, maybe I'll leave it at here, and we'll have 5 minutes for questions. Do you want to add anything?
Yeah, just one of the upcoming features that was mentioned earlier this week is job triggers. So this work that you're seeing here of making those model, well, we had feature generation and inference dependent on the DBT models having been run. That can happen in one DAG, or that could be a job dependent on another workflow as well.
Yeah, and you can even set it up so that you can choose a storage account like an S3 bucket or an ADLS container with specific prefixes, so that whenever new data comes in, you can trigger a job. So you can even have your DBT models run whenever new data has come in with autoloader and things like that. So that way you can really model your dependencies more directly to what you actually need, as opposed to the timing that's involved.
So I mean, just to call out one last time before we take a few questions, the idea with the lakehouse is that we can serve these use cases end to end. So what we're looking for every time is like, where is there friction? How can we remove that? So this Git repository integration saying, well, actually, when I run a job, I just want you to pull the latest code from main or whatever branch or tag you want to use. That removes some of the friction for certain folks. So we want to continue to keep doing that. So please let us know if you do have any requests to make your end-to-end journey simpler, because they're the things we look to prioritize all the time. So we're 3.5 minutes. Any questions? And we have a mic. Wow. Okay. Well, whoever's got the microphone can choose who gets the question first, because all I can see is like a bright white light.
So can you trigger a job from like ADF? So if we need to get like a source system that isn't compatible with Databricks, can we use like ADF to get the source data in and then trigger a job in Databricks?
Yeah, so
repeat the question, for folks.
So the question was whether you can use ADF to trigger a workflow that exists in Databricks. Is that correct? Yeah. So today, what you can already do in Azure Data Factory is run notebooks and other types of objects within the lakehouse. We're working together with Azure to build that integration further. What some customers are doing is using the Jobs API directly to do that. So our Jobs API is quite extensive, so that allows you to be very flexible in what you want to do. But we're working with ADF to further that integration.
Okay.
Yeah.
Next
my
question
is, how do we do the trigger rules that are available in Airflow? Do we have any setting where we can do the trigger rules? Like if the flow is going on, is there any success path, a failure path?
Okay. So if I understand correctly, your question is about alternative dependencies between tasks. So when depending on the task state, right? So when a task has failed, run this cleanup task. So we're launching that very soon. So that's going into private preview in about a month from now. So if you're interested, you can send me an email at jan@databricks.com, and I'll make sure to get you signed up.
Yeah.
But conditional execution is something we're tackling in the next.
Task values itself has just been released, so you can see the progression there, and the conditionals are on their way. Okay. Okay.
Sorry. Let's talk about it after. I can't.
Yeah.
Yeah, I just wanted to know if there was a way to codify the workflow. Right now, everything that we have is, documented in Git in terms of, like the Airflow DAGs, it's a pipeline file. Is there a similar thing, or do you have to always go to the UI to kind of create your workflows?
Yeah, so I'll take this one. The question is, do you have to always go to the UI to create the workflows? If you've created a workflow in the UI, you can take the JSON. You can also manipulate that JSON, and you can store that JSON outside. We are looking at options to actually provide an SDK. We're still in the kind of ideation phase of that, so we'd love to get your input about like what would make that easiest for you.
Yeah, maybe to add something to that, there are tools like Terraform, and DBX to make this easier. But we're looking into a more native experience there. But it's high on our priority list.
Yeah.
Yeah, that would be amazing if it becomes part of the DBX project, because our organization has recently adopted it and we're loving it.
Yeah.
I guess I just have one more question for you before we can dish Airflow onto workflow. I need the concept of execution date, the logical date for some backfills. It's not depending on current runtime.
Yeah.
So is that something in your roadmap, or in the meantime, what workarounds can we use?
Yes, so we're running out of time. We are tackling that the second half of this year. And I would love to reach out to talk a bit further about it. And we do have a workaround available that is applicable to some cases, so I can work with you on that.
We'll take 2.
Okay, last one.
Sorry. Two very short questions. One about in Airflow you can have alert on a retry and alert on a fail. Currently it doesn't exist on workflows, right?
Sorry, I don't think I
And on Airflow there is an option to specify alert on fail or alert on retry. Currently it just spams every transient failure that was. It sends an alert on PagerDuty, which people don't like me now.
So we're that's the same question as she was asking. So that is coming in private preview 1 month from now. So that's like allowing you to specify different task states and when to run specific tasks. So that's coming very soon.
And the alerting on that.
And alerting on that, yeah, that we will allow the control over under what circumstances to alert.
And will there be a possibility to customize the alert with the Slack API, not just email?
Yes, so there's a new feature coming called webhooks. So that allows you to basically specify custom webhooks, which allows you to call into Slack, into PagerDuty, into whatever notification systems you're using, so that you can basically automate your journey.
It was mentioned in the keynote as well, the webhook things. So, okay, thank you very much, everyone.
Thank you.